Hello and welcome to another NGen Math 8 lesson by eMath Instruction. My name is Kirk Weiler and today we're going to be doing Unit 7, Lesson 4 on negative and zero exponents. Now you've worked with exponents for quite some time now. I mean, as early as 4th grade, you were working with exponents. And there has been one consistent thing that has been true about every exponent you've ever worked with, and that was that it was a positive whole number. But today, we are going to look at exponents that are 0 and negative, all right? And eventually, not today and not in this course, but in high school algebra courses, you will look at exponents that are fractional. How cool is that? All right, well, that being said, let's kind of jump into it. All right, now, we have an additional exponent property that we need to kind of figure out before we move into these, negative and zero exponents, okay? And we can actually deduce or come up with that exponent property by simplifying fractions like we did in our last lesson. So let's review that process in exercise number 1. Simplify each of the following and then write the general property in D. All right, great. So let's take a look. And I'm going to write this first problem much bigger for you. 8 to the 5th divided by 8 to the 2nd. Now remember, when we simplify fractions, as we did in the last lesson, right, you've always done it in the past by just figuring out the largest thing that divides into both the numerator and denominator, and you do that division and go merrily on your way. That's a lot more confusing when you look at something like this. So what we did in the last lesson is we said, hey, if I've got the same base down here as what I have up here, then I can use that product property of exponents, right, to rewrite this numerator. In other words, I can write this numerator as 8 to the second, times 8 to the 3rd, all divided by 8 to the 2nd, times 1. I'll just write it like that, all right? Now remember, we can also take fractions and break them up into products, in which case, this is 8 to the 2nd divided by 8 to the 2nd times 8 to the 3rd divided by 1. But what we reviewed in the last lesson, and what is hopefully painfully obvious to you, is that any time you have a quantity divided by itself that's equal to the number 1, in which case this is 1 times 8 to the 3rd. I don't really have to have this 1 down here, and that's 8 to the 3rd. All right. Now, oftentimes, by the way, students will actually shortcut this, and get to this almost immediately by basically looking at this and going 8 to the 2nd divided by 8 to the 2nd is equal to 1. And that leaves me just with an 8 to the 3rd divided by 1, which is 8 to the 3rd. Some math teachers and a lot of students will refer to this as canceling the 8 to the 2nds. All right, and I probably will use that terminology as well. It's not really like great mathematical terminology. We really shouldn't say canceling 8 to the 2nds. We should probably say 8 to the 2nd is divided by 8 to the 2nd and it's equal to 1 and then 1 times anything, but that takes a lot of time. Anyway, suffice it to say though, 8 to the 5th divided by 8 to the 2nd is 8 to the 3rd. I'd like you to do the same process for B and C. All right, then we're going to come back and we're going to talk about the general property in D. Pause the video now and go ahead and do this. All right, let's take a look at letter B. So again, let me write it a little bit larger. 5 to the 11th divided by 5 to the 4th. We can take that numerator and factor it into 5 to the 4th times 5 to the 7th, all divided by 5 to the 4th. I'm now going to cancel those because they divide out and they leave me with a 5 to the 7th. And I don't need to evaluate that 5 to the 7th. It is what it is. I could use my calculator to figure it out. And you will want your calculators today. So if you haven't broken them out yet, make sure to have those handy. Now let's do one where the bases are variables. Here I've got x to the 6th divided by x to the 2nd. So the numerator I can factor as x to the 2nd times x to the 4th, and here I'll just leave as x to the 2nd. We can cancel those two, leaving me with just x to the 4th. So when we look at each one of these problems, 8 to the 5th divided by 8 to the 2nd, I got 8 to the 3rd. 5 to the 11th divided by 5 to the 4th, I got 5 to the 7th. x to the 6th divided by x to the 2nd, I got x to the 4th. So now, what is that general property, right? X raised to the a divided by x raised to the b is going to be equal to what? Pause the video now and write down what you believe is the general property when you divide two quantities that have the same base. Well, hopefully it's pretty obvious. It's going to be x to the a minus b. And that should make a lot of sense, right? Because when we multiply two things that have the same exponents, when we multiply two quantities that have the same base, that's the number or the variable, that's being raised to the power, then we add the two exponents. So when we multiply two things with the same base, we add the exponents. And when we divide things with the same base, we subtract the exponents. Now, one dicey thing about that, though, is that subtraction, unlike addition, is not commutative, all right? And that kind of makes sense because division is not commutative. It matters which one's in the top and which one's in the bottom. And specifically, when we've got x to the a divided by x to the b, that's x to the a minus b, all right? That's always the power of the numerator minus the power of the denominator, always, all right? So let's keep working with this particular property, very, very important property of exponents. All right, now the subtraction property of exponents makes a lot of sense when the power in the numerator, in the top, right, is larger than in the denominator. But what if the exponents were equal, right? What if they were equal? So let's take a look at that in exercise number 2. Consider the expression 2 to the 3rd divided by 2 to the 3rd. Letter A. If you applied the exponent law from D above, so the one that we came up with in general, what would this expression equal? All right, so pause the video now and just use that exponent law that says, hey, if you divide two things with the same bases, just subtract their exponents and tell me what this thing should be equal to. Pause the video. All right, well, based on the exponent law that we just saw, 2 to the 3rd divided by 2 to the 3rd should be 2 to the 3 minus 3, which should be 2 to the 0. And for the first time ever, we're seeing a 0 exponent, right? Just based on that subtraction property. Now let's take a look at letter B. If you just simplified the fraction, what would it equal? In other words, if I just took this fraction and I said, what is 2 to the 3rd divided by 2 to the 3rd, right? What should that be equal to? We've talked about this a bunch in the last lesson and even some today. Pause the video now and write something down at the end of that equals sign. Well, that should be equal to 1. Anything divided by itself is equal to 1. Now, for these two things to both be true, and they are both true, if 2 to the 3rd divided by 2 to the 3rd is 2 to the 0, and 2 to the 3rd divided by 2 to the 3rd is equal to 1, well, that means that 2 to the 0 must be equal to 1. And in fact, that gets at our general exponent property for 0 exponents. And it is one of the most interesting exponent properties of it all. Any base raised to the 0 is equal to the number 1. Any base raised to the 0 is equal to the number 1. All right? And that's a little strange, right? That is a little bit odd, okay? Now, one way, hopefully, you could feel comfortable with that. So the development of it is really just strictly from that subtraction rule of exponents. But one way to feel a little bit comfortable with this, just let me digress just for a moment. One way to feel comfortable with this is even just thinking about something like this. If I had 4, right, to the second, right, we are all comfortable with the idea that 4 to the second is equal to 4 times 4. But we could also look at that as saying that 4 to the second is the same as multiplying the number 1 by 4 twice, right? So 4 to the second is 1 times 4 times 4, or 4 times 4 times 1, right? So in other words, we could actually interpret exponents as how many times should we multiply the number 1 by this base, right? And of course, that would give us 16. Well, that would kind of mean then that 4 to the 0 would mean that I should take the number 1 and multiply it by 4 0 times. Well, if I take the number 1 and I multiply it by 4 no times at all, well, I'm still just sitting at the number 1, right? So we oftentimes think about exponents as, oh, you know, 4 squared is 4 times 4. But really what 4 squared is how many times I should multiply the number 1 by 4, all right? You know, and it gives me 16. You know, 4 times 1 gives me 4, and then 4 times 4 gives me 16, right? So 4 to the 0 means, hey, don't multiply the number 1 by 4 at all. What do you get? You get the number 1. And that's it. Now again, one of the beautiful properties of this is it is true for any base. Negative, positive, rational number, fraction, doesn't matter. The only number, in fact, raised to the 0 power that's not equal to 1 is the number 0. And we'll explore that just a bit in a little while. Let's take a look at letter D really quickly. How would 5 times x to the 0 simplify? Think about this for a moment. All right, and trust me when I say it's not as straightforward as you might think. Remember your order of operations. So, tell me how that would simplify. Pause the video now and give it some thought. Well remember, right? Remember that with exponents and multiplication, which we've got both going on here, right? This is 5 times x to the 0, right? That exponents come first. So this comes first. All right? So, you know, the answer to this problem isn't the number 1. It's actually 5, right? Because 5 times x to the 0, given our order of operations, which say exponents come before multiplication, that would imply that I should first take that x to the 0, turn it into the number 1, then multiply by 5, and I just get 5. Now that would be very different than this. This, well, that would be equal to the number 1, because anything raised to the 0 power is equal to 1. I don't care what's inside of here as long as it's not 0. But this, we would first have to evaluate the x to the 0, have it equal to 1, and then multiply by 5. Now again, this is a strange idea, a 0 exponent. It really is strange. And one thing that can kind of help us get grips on things is our calculator, right? It at least gives us some sense for, oh, okay, well, the calculator knows that property. So, you know, the fact that any number except 0 raised to the 0 exponent is equal to 1 is remarkable, and it is definitely hard to grasp at first. So let's play around with it just a bit on the calculator, all right? Exercise number 3. Use your calculator to verify the 0 exponent property. All right. Now notice, as always, when I have negative numbers raised to an exponent, it's really important that they're enclosed in parentheses, not just on my paper, but also on my calculator. So let's take a look at one of these together. Let me bring my calculator up and let's take a look at 25 raised to the 0. Okay. So I'm going to just do 25. I'll use that caret button for the exponent. Raised to the 0, enter, is equal to 1. Right? It's that simple. What I'd like you to do is go through each one of the remaining ones and make sure they are equal to 1 as well. Pause the video now and go ahead and experiment. All right, well, let's take a look at a decimal raised to the 0. So if I take 0.25, 1/4, right? Raise that to the 0, enter. Look, that's equal to 1. Now again, I want to be careful here. I'm going to put parentheses, -3, parentheses, raised to the 0 is equal to 1. And again, the reason I want to do that is that if I leave the parentheses off, okay, right, notice I get -1. And that's not because -3 raised to the 0 is -1. It's because when written like this, order of operations insists that we first do the 3 to the 0 and then we multiply it by -1. And I know that seems really ridiculous, but that is just kind of the way it works out with these, and that's why It's critical to enclose negative numbers in parentheses before you raise them to powers. Anyway, let me just cross that out. All right, and let's do the negative 22, right? That's, again, simple enough. I'll do negative 22 raised to the 0. Trying to raise to the 0, there it is. And it's equal to 1. It starts to get boring after a while, right? I mean, I can be like 1 million raised to the 0. Look, it's equal to 1. And again, it's really cool because I can really think of exponents as basically telling me how many times I multiply the number 1 by the base. And so really, it's like, well, take the number 1 and multiply it by 25 0 times. What do you have? Oh, I've got 1. Take the number 1, multiply it by 0.25 0 times. What do you get? The number 1. It's basically saying take the number 1 and do nothing. What do you still have? The number 1. Now, the one exception to this rule is 0 raised to the 0, and that's kind of cool. So I'd like you to pause the video right now and put 0 raised to the 0 into your calculator and see what you get. Well, hopefully your calculator kind of went berserk. It gave you an error. It gave you like, I can't do this. What are you, crazy? You know, whatever. You know, hopefully it's not insulting or anything. But, you know, maybe there's calculators out there that are. On my nice Texas Instruments 30XS here, if I put in 0 raised to the 0 and I hit enter, I get a domain error. And again, any other number that you raise to the 0 power, you're going to get 1. But here I get an error, all right? Whatever a domain error means, let's not worry about that right now. It does have a little bit to do with the domain of a function, but I wouldn't be too concerned about that. You know, one of the things that's kind of cool about 0 to the 0 and why calculators and generally math have a hard time with that is it's almost like two immutable rules of math are coming in conflict with each other. One of those rules is that if I raise anything to the 0 power, I should get the number 1, okay? The other one, though, is that 0 raised to any power, right, is equal to 0, right? If I have like 0 times 0 times 0 times the number 1, I should get 0, right? So there are these two kind of conflicting rules that occur. 0 raised to any whole number power or any positive power is going to be 0, and yet anything raised to the 0 should be equal to 1. So which one wins? And the answer is neither one of them wins. 0 to the 0 just doesn't have an answer. It's not 0, it's not 1, it's not infinity, it's not -2. 0 to the 0 just isn't a number. Weird, but true. All right, let's keep going. Now, right, we've got exponents that are positive whole numbers, and now we've got an exponent of 0. Now let's talk about exponents that are negative numbers, right? Or at least negative integers. We have now seen positive exponents and 0 exponents. We're now going to explore exponents that are negative. So let's take a look at exercise number 4. Consider the expression 2 to the 2nd divided by 2 to the 5th. Letter A. Use the exponent law exactly as it is written from exercise 1D to rewrite this expression. All right, now remember that exponent law from 1D was if I had x to the a divided by x to the b, I get x to the a minus b, right? I get the power of the numerator minus the power of the denominator. So why don't you go ahead and use that for this and then just get 2 raised to something and leave it like that. Pause the video now. All right, well, let's do it. So 2 to the 2nd divided by 2 to the 5th, according to that exponent law, should be 2 to the 2 minus 5. And keep in mind that 2 minus 5 is not 3. 2 minus 5 is equal to -3. So now we have a negative exponent according to this law. Okay. So what we're going to do is we're going to do exactly what we did in exercise 2. I'd actually like to know what this is equal to when I simplify it using what we learned in our last lesson. So now let's take a look at letter B. Evaluate the original expression by factoring the denominator and simplifying. Okay, so why don't you go ahead and do that? We did this in the previous lesson, right? When we had the power in the denominator larger than the power in the numerator. Why don't you go ahead and simplify that? All right, and let's see what we get. And again, you can leave it as something involving 2 raised to a power, but why don't you go ahead? All right, so the numerator, I'm just going to rewrite as 2 to the second times 1. The denominator, I'm going to rewrite as 2 to the second times 2 to the third. Okay? And I do this in the denominator so I can cancel those 2 to the seconds out. So I can say, well, 2 to the second divided by 2 to the second is equal to 1. And then all of this is 1 divided by 2 to the third. So what can I say? I can now say, because this is equal to this based on an exponent law, and this is equal to this just based on factoring and canceling, that 2 to the minus 3 must be equal to 1 divided by 2 to the third. And that's really what a negative exponent tells me. Now think about what I just talked about with like positive exponents tell you how many times you should multiply the number 1 by that particular base, right? So like 2 to the 5th tells me multiply the number 1 by 2 5 times. So what do negative exponents tell you? They tell you how many times you should divide the number 1 by that base. And that should make sense, right? Positive exponents are saying, hey, multiply the number 1 again and again and again by 2 or 5 or x or whatever the base is. Negative exponents then say take the number 1 and divide it by the 2 this many times. So let's take a look at letter C. Letter C. Based on A and B, fill in the general exponent property below about negative exponents. All right. Well, there it is. B to the minus n, right, really says take the number 1 and divide it by b to the n. Negative exponents indicate division of the number 1 by this base this many times. Okay? So let's apply that and then use our calculator to check. Let's take a look at letter D. What would 2 to the negative 2 equal? Evaluate using C, what we just came up with, and then verify on your calculator. All right, we'll take a shot at this on your own. Pause the video now. All right, well, here we go, right? According to this exponent law, 2 to the minus 2 will be 1 over 2 to the second, and of course we know that 2 to the second is 4, so it should be 1/4. Right? If this exponent law is correct, right, that 2 to the minus 2 really means take the number 1 and divide it by 2 squared, then when I take my calculator out, it should tell me that 2 to the minus 2 is equal to 1/4. And there it is, right? Now it gave it to me in decimal form, 0.25, but obviously 0.25 and 1/4 are the same numbers. All right? That's really kind of cool. So 2 big pieces today, right? One of them being that when I raise any number or variable to the 0 power, I get the number 1. And when I raise any number to a negative power, I can transform that into 1 divided by the number raised to the positive power. So let's get a little work on this. Let's take a look. Now, negative exponents tell us to divide repeatedly by the given number, specifically to divide the number 1 by the given base. Practice with negative and 0 exponents is essential because let's face the facts, they're weird. They're strange, right? I mean, it makes so much sense to be like, yeah, 3 to the 5th, that's just 3 times 3 times 3 times 3 times 3. 3 to the minus 5? That's weird, all right? So let's get some practice. Exercise number 5. Rewrite each of these expressions. Leave in simplified fraction form. All right, so what I want to do, right, is I want to not only rewrite these things with, no negative or 0 exponents, but I also want to like come up with actually what those numbers are equal to. So something like letter A, right, where we've got 3 to the minus 2, this is just going to be 1 divided by 3 to the positive 2, and 3 squared is 9, so that's going to be 1/9. What you absolutely positively do not want to do right now is just pull your calculator out and put in 3 raised to the negative 2. That is not math, that is button pushing. And trust me when I say this, no one in this world is just going to pay you money for punching buttons on a calculator and having no idea why you get the results you get. So make sure that you're doing these by hand as much as possible, Let's take a look at letter B, right? 5 to the negative 3. 5 to the negative 3 is going to be 1 divided by 5 to the positive 3. And let's think about that one in our head, right? What is 5 to the third? 5 to the third is 5 times 5 times 5. Well, 5 times 5 is 25, right? Times another 5 is 125. So this is 1 divided by 125. Sorry, had to sneak it in there. All right, and let's do one more of them together, and then I'll have you work on the rest of them on your own. 7 to the 0. That one's quick. 7 to the 0 is equal to 1. It's just like, I love the ones where it's to the 0 power, because there's not much to them. All right, so pause the video now and finish off the rest of these. Only use your calculator when you absolutely have to. All right, well, raising a number to the negative 1 power, that's actually kind of almost a special case, all right? There's even oftentimes on calculators a little negative 1 exponent button. There oftentimes is. And because 6 to the minus 1 is just 1 over 6 to the first, but that's just 1/6. So whenever we raise something to the negative 1, what we're doing is we're finding its reciprocal. So 5 to the negative 1 is 1/5, 7 to the negative 1 is 1/7, 20 to the negative 1 is 1/20, etc. 10 to the negative 4, that's the largest exponent I've got on here, but since the base is 10, it still should be pretty easy. That's 1 divided by 10 to the 4th, which is 1 divided by 10,000 with an extra large fraction bar. All right, 11 to the 0, that's equal to 1. Okay, 4 to the minus 1 is very similar to the problem up there. That's going to be equal to 1 over 4 to the first, which is 1/4. And finally, 8 to the negative 2, this is going to be 1 divided by 8 to the second. 8 to the second is 64, so 1/64. All right, absolutely critical to get good practice on this. You will be amazed in Algebra 1, in Geometry, Algebra 2, but especially the algebra courses, Algebra 1 and Algebra 2. You'll need to deal with especially negative exponents quite often, and every once in a while you'll see the 0 exponent rear its ugly head. It's not its ugly head, it's a beautiful exponent property, it's just a little strange, that's all. All right, so let's take a look at one more. We can combine exponent properties in order to simplify or evaluate more complicated exponential expressions. So let's take a look at exercise number 6. Write the expression 10 to the second raised to the negative third in simplest form. All right, so we've got a bunch of different exponent properties going on here. One of them happens to be when we have something raised to an exponent raised to another exponent, we do something with those exponents. I'm not going to be a spoiler alert, I want you to try to remember what those are. That's the first thing I would do, is use that property. When I have something raised to an exponent raised to another exponent, right, I do something with those two exponents. Once I've done that thing, then I want to take the 10 raised to that exponent and do something else. So pause the video now and see if you can work through this. All right, well remember, when I've got something raised to an exponent, here let me write this larger, 10 to the second to the negative third. When I have something raised to an exponent, then raised to another exponent, I multiply the two exponents. Now previously we had only done that with two exponents that were positive. But the exponent rule is the exponent rule. It should work with any types of numbers whatsoever. So 10 to the second to the negative third is going to be 10 to the 2 times negative 3, and of course a positive times a negative is a negative. Now we can have that exponent rule that says, hey, if I raise something to a negative exponent, that's going to be 1 divided by that number to the positive exponent, 1 divided by 10 to the 6th. And 10 to the 6th is one of my favorite numbers out there. It's 1 million. So this is all going to be 1 divided by 1 million, or 1/1,000,000th. A little bit hard to say, but yeah, 1/1,000,000th. And there it is. All right. So negative exponents, zero exponents. Let's wrap this thing up, right? You have almost always exclusively dealt with exponents that are positive whole numbers, 2, 3, 4, 5, etc. Today, for the first time, you've really started to grapple with the idea that exponents could look different than those. Now, one thing that is helpful is to always think of an exponent not as how many times you're going to multiply a number by itself, and I've even used that phrase a ton, right? But how many times you're going to multiply the number 1 by a particular number. That helps us to understand both zero exponents and negative exponents. Because if I've got something like 5 to the 0, and I think, well, if I take the number 1 and I multiply it by 5 0 times, then I just have the number 1. Likewise, if I had 5 to the negative 2, that would imply taking the number 1 and dividing it by 5 squared. All right? Negative exponents indicate dividing the number 1 by that base that many times. Zero exponents just tell us that the result is equal to the number 1. We're going to get a lot more practice on this in the next lesson. In fact, that's what that lesson is going to be exclusively devoted to. For now, I just want to thank you for joining me for another NGen Math 8 lesson by eMath Instruction. My name is Kirk Weiler, and until next time, keep thinking and keep solving problems.